Alright, so we've got a cylindrical soft drink, really badly can here. Let's say that's R and that's H. So we know that the volume, being pi r squared H, in this case of a cylindrical soft drink, and we know in this case that the volume is 250. That's what it equals. Now, if you're minimizing or maximizing, you need to get rid of a variable. So we're also interested in the total. So usually, this is scaffolded. Say they then said something about minimizing or maximizing the total surface area. We'd go, all right, so what's the surface area? Usually I write A, but okay, let's write S, surface area. It would be 2 pi r squareds and then a pi rh. Right, because you've got to, you break this in, you kind of cut it and break it into a rectangle, the height being the height, and then the length of that rectangle being the circumference, which is 2 pi r. Oops, so 2 pi r h, there you go, that's when you find your errors. And then you've got the two circles on top and bottom, so that's where the 2 pi r squared comes from. Now, if you want to maximize, in this case minimize, we need one variable. At the moment we've got r and h in there, so really we usually often want to get rid of h. So we need a different equation where we can make h the subject so that we can get rid of h. So if we divide through by pi r squared, there, we've now got something we can sub in for h. So here we've got 2 pi r squared, here we've got 2 pi r, and if I sub in 250 on pi r squared, you will notice I can get rid of pi and I can get rid of one of the r's. So I get a 500 on r there, which gives you this equation here. Right, that's how we show. So this really is it's scaffolded, but really you should know to do that. So you need to get rid of one of the variables so that we can now minimize it. All right, so now we've got this equation, and we would really, for calculus, we would make sure it's in index notation. So we've got 500 r to the minus 1, just makes it easier. If we want to minimize it, we know we need s dash, so ds dr. So we're going to have 4 pi r, here we're going to have minus 500 r to the minus 2, and we're going to need s double dash at some stage to show its minimum, so 4 pi, here we're going to have plus 1000 r to the minus 3. Alright, so remember to minimize or maximize, we want s dash equal to 0. So we've got 4 pi r minus 500 on r squared. We want that to equal 0. So let's have a look at 4 pi r equaling 500 on r squared. Then we've got 4 pi r cubed equaling 500. Let's actually just divide by 4 pi there and cube root that. Alright, so it says show that r equals 5 on, alright, so 500 divided by 4 is 125, so this is the cube root of 125 on pi. We know the cube root of 125 is 5, so now you've got the cube root of pi, which is the same as pi to the third. Alright, so that's how we show it. We show that s dash equals 0 when r equals 5 on pi to the power of a third. That gives you your global minimum. We better show it's a minimum as well. So how do we show it's a minimum? We sub into s double dash that point. So that point in there. So we get 4 pi plus 1000 over r cubed, and remember r cubed, if I look at r here, or look at here, r cubed, there we go, r cubed. So over r cubed being 125 on pi. Alright, and you can see that's going to give you a positive. Positive means you're going to get a minimum there. So we can prove that it's a minimum, that's fine. Show that to minimize surface area of the can, the diameter of its base should equal to its height. Alright, so it's talking about the diameter and the height. Well, we know what r is to minimize it. So let's have a look at what the height would be, so remember the height came from this equation here. As usual, my working is just so well set out. So you've got 250 on pi r squared. All right, so we want to square, so that becomes 5 squared, and square this as well, so it becomes 2/3. Remember, you've got 1 here, so 1 minus 2/3 is 1/3. Well, let's do 250 divided by 25 is 10 to start with. And then here you've got pi to the power of 1 minus 2/3, which is 1/3. So that would be the height. So here's, you've got the height, you've got the radius. It talks about the diameter. Diameter is 2 times the radius, which is 2 lots of that, which is 10 on pi to the 3rd. So you can see both the height and the diameter should be equal in order to get this minimum surface area. Okay? So setting out, not great. You may want to look at the textbook to see it set out nicely, but hopefully the explanation helped you understand.